Hey, Mr. Michael.
Hey, Sydney, how you doing?
Good. I just came off of my math lab and saw that our midterm is till tomorrow.
That's right.
Okay, just wanted to double check to make sure that wasn't like an error or whatever, because I don't like.
No, I mean, today is our review day, and Thursday we're going to get started with new stuff. I'll show the calendar.
Hi, Professor. How you doing today?
Good to meet you.
Are we going over the midterm today?
Yeah, that's what we. I was going to go through there and see if you have questions. I don't know if we have time to go through every one of those problems on that practice.
Okay, thank you.
You let me know. So see, this is the 19th. So this is review. And like I said, the exam is open. It sounds like till tomorrow, and that's what I would expected. I thought
Okay.
it yes.
Okay, great. Because I must do a lot of studying today and take the practice and then take the midterm tomorrow.
Yeah, tomorrow's the 20th. Okay, so that's right. All right, so can you refresh me with your name again?
Helen.
Helen, okay. Usually by midterm, I would like when people say this semester being a disaster. All right, so let's just look at the practice and y'all let me know what you have questions about. I'm gonna,
Are you recording right now?
it's supposed to record automatically. Let me see. Yes, it shouldn't be recording. It says it's recording. All right, like this was the first thing that we looked at. Can you see that? The distance?
Yes.
That was like the first thing we did. I'll just leave it up to you whether you want me to go through that. That's where you just use that Pythagorean theorem, basically the square root of so we got 2 points. Oops. All right, so it was find the distance. So do you remember how to do that?
You could show us right quick.
Okay. So what it is, D is equal to the square root of the difference between the x's. What's the difference between the y's? All right. So you can mark them if you like. That kind of helps me.
Yeah, I do that too.
Because I'll mix them up otherwise if I'm in a rush. So this is x2 minus x1 and y2 minus y1. All right, so we can just throw those in there. So that distance is going to be equal to 15 minus 3 squared plus 7 minus 2 squared. And the squaring is just so you we don't end up with a negative sign in there. We have positive values. So then we got 12 squared plus 5 squared. So that's 144 plus 29, which is 25. 169, and this one happens to be a perfect square. That's not going to happen all the time, but you might want to double check that. That seems awful nice. Usually they come out to be some kind of a square root. That's going to be 13. Okay. The midpoint is very similar with that midpoint. It's just the x2 plus x1 over 2 and y2 plus y1 over 2. You're just basically finding the average of 2 points. So what do they got? 6, 10, and 8, 4. Okay. So that midpoint is going to be, again, hopeless unless I do this. All right, so it's x1. So that's 8 plus 6 over 2. And remember, this is going to be a point. And then this is 4 plus 10. Where's everybody at today? Four people. All right, and then we just simplify that out. So that's 14 over 2 and 14 over 2. And so it's just going to be 7, 7. Okay.
Yes, thank you.
One moment, please.
What's that?
Yeah, I have to copy the bottom part, just this last part.
All right, the next one, it just asks whether this is a function or not. Anybody got any guesses on it? You know,
I think it is.
from later on that this is actually a special kind of shape. We actually use completing the square to find these things. This one is one, it's a circle with 0. 0 is the center. And then 13 is the radius. So if it's a circle, what does that mean about functionality? What does that mean about the functionality? Is that a function?
Yes.
No, because the reason why I drew it out there is because that allows you to use a vertical line test. But let's go back to this and then just look at the x squared plus y squared. Basically, what it comes down to, if anything is being done to y like that, squared, or if it was an absolute value of y, then it's not going to be a function because you can mess with x, but not with y. Because when you've got y squared, there's no way to solve for y and just have one output. Okay.
Gotcha. Gotcha.
Okay. So this is not a function. And that would apply to something as well, like see, if you just got a parabola, that's a function. But if you do something to the y, let's say x is equal to y squared, see, that's not a function because you can see something's being done to y here, you got a y squared up there, and you got a y squared here. That blows the whole function premise because of the fact that there's no way to solve it for y without getting two values. In other words, every x is going to have multiple y values. See, like for example, here 5 has a value here and here, a top one and a bottom and a positive and negative, and same thing with the green. Like if you have 5, you got a point here and a point there. That breaks the function rule. Each value is going to x is going to have one output. But for the blue one, you don't have that problem. See, and that was also kind of why the function, when you're dealing with a function, your input is just, I'm sorry, your domain, your input, your domain is always all real numbers, negative infinity to infinity. All right, what about this? This is where you plug in. Let's see, how many of them are on here? We might have enough time. Something that's been too much time on. All right, so this we got f of x is equal to x squared plus 5x minus 4. All right, and then the first thing was find f of 8. What does that mean?
You plug in 8 into all the x?
Yeah, that's all there is to it. As a matter of fact, all of these, it just means put that value in place of x. All right. I wonder if anybody else is going to show up. All right, so that's 100, I believe. Take it real quick. And what was mentioned was x plus 2. And so this also means just plug in x plus 2 plus x in place of x. All right, just please, folks coming late. We're reviewing because there's a midterm exam active now, and it's active due tomorrow night. You got to finish it before stroke of midnight. All right. There's practice, and that's what we're going through.
So, my Wi-Fi. So if I'm taking a test, and if my Wi-Fi acts up, coming up.
Well, you should be able to start it back up.
No problem. I don't want it to be like.
I can check it. But I mean, I'm pretty sure I got that because that is a good point. I had, for some reason, whenever I copy stuff from teachers, some teachers don't like giving you to contact them. But I'm pretty sure if a temp is interrupted, students may re-access and complete on their own. Yeah. All right.
That was a good question. Thank you for that.
And it's a good idea for me to check, because like I said, if we got the standard course, and some teachers, I don't know why they take that off. And then, you know, of course, that does it. All right, so let's see, who's come in? Juan and who else? Okay. All right, so this next one is this x plus 2. So we're going to go through and put it in for x. That means then this thing is going to be squared, which is going to be the hardest part. I'm going to do it quick, but you can take that and pull it out as x plus 2 times x plus 2. In Math 097, they have, they do show it, but I know not everybody picks it up. But x plus 2 squared is x plus 2 times x plus 2, and you can pull it out. But there's a shortcut for it, and that's what I'm actually going over that. Oh, we just went over that right before midterm in 097. We went over chapter 5. The way it works is when you square in a binomial, that's going to get squared. The 2 is going to get squared, so that's a plus 4. And then the way you determine that middle one is bring down that sign, multiply these two, so 2x times 2 is 4x. So that's a short way to do it. But you can always FOIL it out. All right, so what do we got here? Like terms. All right, so that means x squared plus 9x. And then let's see. Well, these 4's take each other out, so we got to simplify it. And then the last one is the most useful thing we've learned so far. And that's just doing this thing f of negative x, because we've been using that all over the place. We use it to determine whether functions are odd or even, both of those. And then we also use it to determine symmetry. So all kinds of ways to use this.
So when it's the x squared 9x plus 9x plus 10, we don't leave it like that. We have to simplify it more, you say?
There's nothing else you can simplify, is
Yeah,
there?
that's what okay. I thought I heard you say simplify. That's why I was like, what? Okay.
We're simplifying it. I'm gonna said something silly, but that's all we can simplify. All right, so this right here, see, that one's going to get squared, so it goes back to being an x squared. And then this one changes to a 5x negative because of that negative x. The negative 4 isn't affected. But we could tell, too, if we wanted to, about that this is not an even function. It's also not odd either if we were to go to that step. They didn't ask that, but the way that the even works, you know, if you put that in there and it looks exactly like the original one, it's even. That's all I did. See, that's what these things were here. Make it a little bit bigger. All right, this is going to be a little bit long. All right. The domain, this is a function, if you can't tell, but you can, you've got the line there, the y-axis, to help you with the visuals determine that this is a function, because there's no way you can take that. You can move that y-axis anywhere you want, use it as your vertical line. You cannot intersect this thing in more than one place. So this is a function, and the domain of functions is always going to be all reals. Now the range is going to change because the range is the y, and we just got to go down here to the very bottom. Can anybody see what that is? It looks like that's oh, that's 4, -4.
I was just about to say.
Yeah, -4.
To
and then the arms are going
infinity, right?
to infinity. But no matter what happens, this thing's never going to get less than -4. Your vertex would be -4, whatever, and -4, 5 looks like. But the y value, the output, will never be less than -4. Tell by looking at this, because this arm on the right side is just going straight up. And then the one over there, it's a constant. So it's just going to go out to infinity for x, but it's never going to get lower than whatever that is. I guess that's 20. So the zeros of the function are here and here. Remember, zeros are just solutions to what, and that's what they mean when they cross the x-axis, because at that point, the functional value is 0. And what are those? Let's see.
3 and 7.
7, and then it's 6, 5, 4, 3. And that's all there is to it. The left 0 of the function is 3, and the right, oh, they gave us 1 of them. The y-intercept is where it crosses up here. And what is that, 8? I guess each one of these are 1, 2,
21.
18, 19, 20, 21. Yeah, they're going by 1. You got to just check the scale. All right, it's increasing from right just beyond that vertex, and it's going up all the way to infinity. So at that
we don't put, I'm sorry. So for the y-intercept of the function, we don't put 0, 21, just 21.
Yeah, you're probably right. I'm just trying to rush you.
Oh, okay. I'm just asking because you know.
Right. Yeah, I mean, that's safe to do that. All right, so it's increasing from, and that's x is equal to -4 to infinity. And just remember to use the parentheses there, because at 4, it's technically a constant there. So it's just going right up to 4. It's right past 4 is where it's increasing. And it's decreasing from 0, where it cuts that x, the y-intercept. We're looking at x value, so it's 0, and then it's going down to that same number, 4. And then at 4, it sticks, you know, it's 1 point there. It's not doing anything. It's the way to look at it. And it's constant from here all the way back, which means -infinity to 0. Looking at the x. So it's constant from way out there, wherever that arrow is going, all the way to the negative side, and then it's coming over to the y-axis, which is where x is equal to 0. And then here's the relative minimum right there. That's that vertex. So that's, I think we said it was 5.
-4.
5, -4, right? Oh, wait a minute. They're asking what is the number at which f has a negative minimum. So that's the negative. In other words, if we were to take x equal to 5 and put 5 into this function, the functional value would be -4. So I don't know why they have to ask two different things about it. It's a bit confusing. But the minimum is going to be, point. That's why we have to have the X and the Y. But when they say what is the number at which the has a relative minimum, that's asking for that Y output because it's saying for Y, for F. And the functional value is -4. All right, F of -4, well, that's over here, 1, 2, 3, 4, and that's that 21. What are the X values when X is equal to -3? Well, the X values for X is equal to -3. So -3. X is equal to 1, 2, 3. That's -3. Okay. Oh, hold on a second. Okay, when F of X is equal to -3. So what they want, the functional value at -3. So 1, 2, 3. So right there is 4. Okay, they tell us that. I don't really understand what they're asking. They're telling you right there. Oh, what is the rightmost path? Is there more than one? -3. 1, 2, 3. Oh, okay. So the leftmost one is here, 4. And so this one is 6. Okay, I see what they're saying. All right, so I kind of messed it up right there, but this is, they're giving you the functional value of F is equal to -3. All right. So that means you're looking at Y is equal to 1, 2, 3. So then at F is equal to -3, F of X is equal to -3. There are two values, 6 and 4. Okay.
Can you show us on the screen?
There's not only any way to draw on that screen, but look, can you see my pointer?
Yes.
Okay. We're going down to where F of X is equal to -3. So it's 1, 2, 3 down there. That's -3. And when we come across on -3, there's that point right there and that point. Let me put it on the decimal. Well, problem is, I don't know what the darn number of the function is. I mean, they don't give us the function to graph it. But anyway, let me see if I can just blow it up a little bit. So it says when F of X is equal to -3. -3. So -3 is down 1, 2, 3. And then when we go across, we hit the curve twice. Once right there, and that is X is equal to 4. And that's what they tell us. The leftmost X value for F of X is equal to -3 is 4. X is equal to 4. And then we go over here again, and we'll see that it's right on that 6. So, odd, even, or neither?
Even?
What makes you say it's even? Because even means you're going to have a certain kind of symmetry.
Oh, never mind.
And let me kind of see if I can give you a picture. Because like I said, we don't know what that graph is. So see.
Neither.
Yeah, it's going to be neither. Okay, so see like this one right here. These are symmetric. You have a certain amount of symmetry. This one right here is odd. This would be even symmetry. The problem being is with that little tail that's constant there. See that? That little constant tail over there on the side. If there was another one of those over here on the right that was constant, then it would be even. So this is even. And you can't really test it by putting in the negative x because we don't know what the function is. All right, so piecewise functions. Y'all know how to do that? That's just a matter.
You plug in for each one, and if the outcome is greater than, yeah. I mean,
you look at the x value. Okay. All right. So let's go back over to it. So if x is less than 0, then we're going to use the top one. -1 is less than 0. So that means that we're going to find f of -1 by putting it in, was it 3x plus 5? Yeah, 5x plus 3. So you got to put it in the right one, or it's you're not going to get it right because it's piecewise. So this is a -2, right? That's going to be -5 plus 3. Okay, so that one's -2. F of 0, so at 0, then we use the bottom one. Anything that's 0 or greater. So that's just going to be 7, right? Because when you put 0 in,
yeah, it'll be 0. 7 plus, it'll be 0 plus 7.
And then for the other one, you just use the second one again. So it's f of 4 is equal to 3x.
It'll be 19.
Oops, 3x. So yeah, 3 times 4 is 12 plus 7. So 19, right?
Yes.
Assuming that I wrote it down right. Okay. So questions about that?
No.
Oh, it's on the piece of ones. Because sometimes they'll give you one where it's constant and then you don't have to calculate. But this one you actually have to do the calculation of both of them. All right, this is that difference quotient thing. All right, I'm sure y'all want to see that.
Yes.
All right. Let's see if I can copy this and import it in. Because if you don't get it just right. So I'm going to bring it in over here so we don't have to go back and forth. All right, so what we got to do is we got to subtract from the f of x plus h this, okay? All right. So what we're going to do is we're going to find f of x plus h. And I'm just going to do that separately. And then we'll put this thing, assemble this thing together. Because once we get this, we already know what f of x is, because we got it sitting right there. So you see what I did? It's just like that other one that we had earlier where I put in x plus 2 or something like that. So again, this is being squared, so it's x squared, h squared on the end, it's positive h squared. X times h times 2 positive. The sign comes down. So when we square that out, like I said, is you can just do it as small if you want to by just multiplying x plus h times x plus h. I'm just taking advantage of the formula. Okay. All right, so this, is there anything that goes together here? I don't think that there is yet. All right. So that's f of x plus h. All right. Now, this is where most people are going to mess up at, because you're subtracting all of x squared minus 3x plus 9. Okay? And it's all going to be over h. So now what I'm going to do is I'm going to just run that negative sign through. So it's negative x squared. It's the negative of a negative 3x, so that's positive 3x. And then it's negative of 9, which is negative 9. Now, this is usually going to mean that certain things now are opposite signs, and we're going to lose certain things. We're losing this 3x negative and that 3x because those are opposite to one another. We're losing the 9 and the negative 9 because those are opposite to one another. And
we're losing the x squared and the x.
Yeah, and all we're left with is things with h's in them, which is 2xh plus h squared minus 3h all over h. And what that means is we're dividing each one of those terms by h. To kind of keep it simple, since h is a common factor of everything up top.
So it'll be 2x plus h minus 3.
Yes, exactly. But this just to show what's happening and why the h's, or some of the h's, go away. Because h is a factor of all three of those terms. So if you go back, you go 9-7, right before midterm, like I said, we just covered this in Phantom N7, where you divide, that means dividing h into 2xh. So the h's go away because h is 1, so you just got 2x. And then the h into the h squared means that you just got 1h left, and h into negative 3 means you got just the negative 3. So what we got left is 2x plus h minus 3. And then, well, that's all we need to do. What this is preparing people for is in calculus when you, you do an algebra, and then they show you how you use this as a limit first. Then when you get into learning derivatives, you find out it's a whole lot easier than doing this math. So that's why they're doing it. Oops. All right, what does this mean? What does that there mean, the rate of change? Well, let me just write out what rate of change means. It's just then with this guy's word. Okay. So we need the slope formula. Y2 minus Y1, X2 minus X1. And then this is given 2 points. So what we're essentially going to do, well, if you want to know, then it's going to be f of x2, technically, but that's the same thing as f, as y, I mean. So what we're going to do is we got to go in here and figure out what these are. We already know what x2 and x1 are, so that's 2 minus 1 down there. So let's just go over here and find x of 2, f of 2, and f of 1. Okay, so just 7x, isn't it? F of x is just 7x. Easy. So 7 times 2, 14. And then this one is 7 times 1, which is 7. So then what we do up here is we got 14 minus 7 over 1, which is 7 over 1, which is just plain old 7. Okay? So that's just essentially the slope. So what it just means is between those 2 points, in, a line that collects them would change that much. That's what slope is. It's kind of like how steep of a line it is that connects those points. So 7 that's a fair, I don't think a fairly high number, but that's a really good size slope. All right, transformations. All right, so if we have something inside of the function, in other words, f, in this case, the function is a square root. The number inside tells us horizontal shift, back and forth. And the way it works is it's just the opposite of what that sign is right there. So this is going to be on the left where it starts, the left of 0. So it's not, we can rule out C right away because it's not shifting horizontally positive, it's shifting horizontally negative, -3. All right. And I think we can probably just about say that it's this one now. But then the number that's added or subtracted to the whole function there, square root, tells us up and down shift. And that one works just like the number, the way the sign goes. In this case, it's +6, so that means it goes up. So it's this one. So let's just look at that little, let's look at the board on it. That's the basic one. And then when we
X plus 3. Oh.
I was just going to kind of show you.
Oh.
Basically what happens and how we figured that out. Okay. If it's outside, it goes up and down depending on the sign. Inside of here, it works just the opposite. So it's going -3 because it's based upon X minus being in there. So that extra negative sign turns it into X plus 3. So for all functions, that's the way it works. See, so an X minus 3, C shifts it in the positive direction. So you just got to remember that in the one inside of the function is it works just the opposite. Okay?
Thank you.
All right, so domain of this, it tells us it's a function. So generally we can say all real numbers, but there's a problem with the denominator because there are certain values that are going to make this thing undefined. Can you tell what they are, or do we?
Just a refreshment, if you don't mind.
Yeah. Yeah, that's exactly right. Lance, you got it. Okay. All right, so 1 over x plus 13. Is 1 plus x minus 15. All right. So what we do is to find out where it's going to be undefined and therefore it's excluded from the range, we got to set these equal to 0. And I'm going to put not equal to 0, but just treat it like it's an equation. So that just means x can't be equal to negative 13. And the same thing with this one. X minus 15 can't be equal to 0. So x can't be equal to 15. Because if this is a 13 negative, then it's going to collapse into an undefined statement. If this side is 15, then it's going to collapse that side into an undefined statement. So the way that we do this is it's negative infinity all the way up to negative 13, not including it. So we use the parentheses. We're going to union together, and then we're going to go from negative 13 up to 15. And again, we're using the parentheses because we don't want to include it. And then we got another u, and we're going from 15 up to positive infinity. Mm-hmm.
If we would do 1 over x plus 13.
Yeah, you would just replace the 15 with the infinity. If it was just the 1. I mean, this is why we got to have 3 little sections, because it's going to be undefined at 2 different points. So see, and there it is. Right there. But see, like this one right here, it's talking about exactly what you mentioned, Lance. It's talking about just the negative 13. They don't have the one for just the 15, but that's the one for both of them. All right, so we got to add these two together. So we want f plus g of x, which is just going to be equal to x plus 4. Well, let me back up and put an extra step in there. It's just going to be f of x plus g of x, which is then x plus 4 plus 4x squared. And then you can just write it in order. And then again, that's a plain old function, so it's going to be negative infinity to infinity. The only one we're going to have to watch out for is this one here, because you're going to have something in the denominator that can mess it up. All right, this is f minus g. So f minus g is just going to be just f of x minus g of x. So it's going to be the same thing, except we're going to replace that with a negative sign. So that's going to be negative 4x squared plus x plus 4. So that's what we're doing there. Still no problem with the domain. It's still infinity. This is going to be multiplying the two. So it's just kind of, it's not even binomial multiplication. It's just monomial times a binomial. So it's going to be x plus 4 times 4x squared. And so that's going to give us x times 4x, so that's 4x cubed. And then 4 times this is 16. So that's 4 times 4, and then just 1x squared. And again, that's negative infinity, infinity. This is the one we got to be worried about because there's a possibility, well, we're going to have to take into account the domain for the denominator because the denominator is going to exclude certain values. All right. So f of g of x is equal to x plus 4 over 4x squared. Now, what's going to make this equal 0? Well, it's going to be just 0 because there's nothing hanging off the end of it. So this can't be equal to 0. So when you divide both sides by 4, it's still going to be, there's only one thing that's going to make that true. The square root of 0 is 0. So x can't be equal to 0. So that's that right there. Now, I don't know if there's a way to really simplify this thing. I think that's about all we can do. I mean, you could do this. Let's just see. Remember, that just means each one of them separately. So that's just going to be 1/4 there. And then what's going to happen is when you subtract, you're going to have x to the 1 minus 2, which is going to give you a negative x. So you just put it down here. And then this is just 1 over x squared. So that's probably the best way to put it right there. When you take it, check it and see if you let you put that in there. You'll know. You'll be able to come back and take the entry when you sure. But that right there is technically simplified. And you can also still see that x can't be equal to 0 because if you have a 0 in that one, it's going to collapse. Also over here with the x squared. 0 is the only thing that's going to make them fine. Oh, is there nothing? Another thing? Oh, they're upset because I didn't put anything in there. I'm trying to like see what time. All right, so these are just different ones. Why not too far from finish? You only have 15, right?
When I tried to plug it in, it made me leave it as how you had it the first time. Like to x plus 4 over 4x squared.
Yeah. I mean, that's probably fine. That's why I said I thought that would be all right. because that's all we can do is simplify it. And then, because these things right here, you're adding them, and if you want to find a common denominator, it ends up looking like this again. All right, so f of g fog of x. And what this really means, and the way I like to look at it, is just f of, and then you're going to put g of x inside of it.
Hi, may I speak to Kristen, please?
What's that? I didn't see who was talking, so. So with this one, we got f, so that's 7, and in place of x, we're going to put x plus 2. So that's just going to be 7x plus 14, right? And then the backwards is g of f. All that means is g with f of x put inside of it. Okay, so g with f of x put into it. So g is the x plus 2. So we're going to replace the x plus 2 with 7x. That's all we can do, isn't it? So we put f of x in place of the x and g. And so that's all there is to it, 7x plus 2. All right, so now we're going to go back and then find out what these are. So the first, well, they both want 4. We'll just do both of them. So 7 times 4 plus 14 is equal to, what is that, it's 28?
Yes.
28 plus 4, let's see, 42? So that's what that one is. That one's 42. I did it right. My head kind of. And then so on this one, where x is equal to 4, that was 7x plus 2. There's not much difference. So it's 7 times 4 plus 2. So it's going to be 30. So 7 times 4 is 28 plus 2 is 30. All right. Any questions about that one? I'm afraid there's going to be one like showing up as a real.
Mr. Michael?
Hmm?
Oh, you just put, okay, you just corrected. I was going to let you know you put 300 instead of 30. Never mind, you corrected.
Yeah. I would have been filling in all the blanks. It's just a matter of time. But I wanted you to see what those were. In this case, see, this was the fog one, and this is the golf one. Okay. All right, so what does this mean here? What is that asking us to do?
Find the f.
Okay, I'll just try to type this out. To find, that just means the inverse function. F of -1, they're giving us the f over there. So the inverse function is found by replacing or swapping.
That's the, yeah, the one.
Okay, well, first of all, you gotta, let's put replace. Okay, so that's what all we're doing is we're going to write this as y is equal to 8x plus 4. All right, so now we're going to swap. And we're going to have x is equal to okay, so see what I did there? The red ones got swapped and changed.
Yes.
Now we're going to solve for y. Okay, so to solve this for y, well, this is something
Subtract the 4 almost.
yeah, that's probably the easiest way to do it is just subtract that. And so that means x minus 4 is equal to 8y. And then we're going to divide both sides by 8. So x over 8. So 8 in this one, that's all I can do. And then this one gets simplified down to 2. So, and remember, that means the same thing as 1 over 8x. So if you're wondering, because that right there, that's a line, like a linear. So that would be the slope. So notice up here, when it was solved for y, that the slope was 8. And on the inverse function, it's 1/8. Oh, thanks. So this is, wait a second. Yeah, you're right. So that's, yeah, I know.
I was a little.
Yeah, I'm rushing here. So 4 over 8, which is x over 8 minus 1/2. 1/2. There we go. All right.
We need to think about it.
You might be able to. You can just try it.
We would get rid of the x, right?
What's that?
Well, wouldn't we get rid of the x? Would it be just 1/8 over, I'm at minus 1/2? Since we're using the 1 as an x?
Well, what I was trying to do here is show you that x over 8 is the same thing as 1 over 8x. Those two things mean the same. Sometimes you'll see them in different places, but those two things mean the same thing. So whether they'll get mad about that, I don't know. And the reason why I'm not putting these in, because what I would have to do in order to check is I'd have to put it in, submit it, and then go back and look. But that's what I would do to be safe. But I just kind of wanted to bring up the fact that 1 over 8x, 1/8x is the same as x over 8. So that way you can tell what the slope is of the line. It's 1/8.
Sometimes we get, it was, 6x plus 4.
Okay. Should have enough time because I think there's just one more problem on it. Okay, find the inverse of what? 6x. plus 4. What's the rest of it? So in other words, you're saying this, f of x that's what you're saying, right? All right, well, let's come back to that one because we're getting close on time. Let's see what that last problem is. Oh, there's actually 2 more. All right. So this is this is those what we call the complex numbers. In particular, it's I or imaginary. So what we want to do is they want to put it in standard form. It's that. Let's write that here. 6 over 9 minus I. So what you have to do is you have to multiply by the conjugate. And remember, the conjugate is just the opposite. So up at the top, it's 6 times 9. So it's 54. Plus 6i. And then down here, now, remember, this is the difference of squares. And the reason why you multiply it by the conjugate is when you multiply it by the conjugate, you're going to end up with a positive number down there. What you end up with is 9 squared plus 1 squared. And if you don't believe it, just pull it out. So that's 81. That's the 9 squared. Plus 9i. Minus 9i. See, those are going to go away. And then I squared times I. When I times I is I squared. So then this is, these are gone. So that's 81 plus 1. Because I squared is -1. -1 times negative. So this ends up being 82 down here. So this is 54 over 82 plus, this right here is 82. What is it? 9 squared is 81 plus 1. And then we can, anytime we can simplify it, we'll do it. Is there any common factors top to bottom? 54, they're both even. So that's 27 over 41. Let's see what common factors. And so there's your standard form. You got your real part, this is your real part, and this is what they call your imaginary part. That's the form of a complex number. You don't always have to have a real part to have a complex number, but you also don't have to be technically a complex number, even if you don't have the I part. But that's the standard form. It's what we call A plus BI. That's the standard form of complex. Let's see what that last one was. All right. Oh, that's pretty easy because it's 4, 2 is the vertex, right? All right. If this is negative, we don't have to change the sign. We just pull that 4 out. And then that's the sign of the Y. So there's your vertex. All right. So how can we, oh, they don't ask us anything else. I thought I saw something that said graph it. That's all I want to know. If it's in that form right there, it's just a matter of looking and finding it. If it's in this form, you know, like 3x squared plus, you know, 5x minus 6. If it's in that form, you got to use the negative b over 2a thing, all right? So that's the benefit of it being in this format here, as you can tell at a glance at the vertex. It's got to be a negative there. If there's not a negative, you got to account for it. So if this was a positive 4, then it would be a negative 4. But since that's negative, then that number right there is our x coordinate of the vertex, and this one is true to the side. All right, so that's pretty much it. I'll go back to that one. Yes. Is there any other questions?
No, thank you for showing.
I'm good. Thank you very much.
Good questions. I like that. That keeps me busy on my toes because I hate to just get up here and drone on and not know what people are thinking. But anyway, so you got till tomorrow to take that midterm, and it's got to be submitted by midnight or turned into a pumpkin. And because on Thursday we're getting on the new material, all right, because we got to do 4 sections before right around first week of November. And then after that, really, there's just a month left. All right. So let's see.
So we're like, wait a minute, that's supposed to be the review day, not the actual test day.
Well, but it's open today and tomorrow.
Wednesday, not Tuesday, not today. So don't worry about it today. Just, review, look over your homework and everything like that. Redo some of the homework. That way you can refresh and redo and do the content.
Well, if you bring me questions, I would be glad to do that. That's the one reason why I went through this practice, is just because that's the closest thing that you're going to see. I don't mind y'all guiding things, but as it is, I got the impression that when people wanted to go through this.
No, I think she was, her mic was unmuted. I don't really think she was talking to you. I think she was kind of talking to us though.
I know.
Yeah, sorry about that.
No problem. Look, I know that we can't do everything perfect, but I'm trying to as well as we can, because remember we missed a couple of days and all. So
there is one that I'm having trouble on the homework that might be on the test.
What is it?
It says it's on homework 2.5. It was due yesterday. It says use the following functions to answer part A through E. And it says f of x is equal to 3q.
Let me see if I can find it real quick. Because I want to get a picture in my head. So it was 2 point what?
2.5.
And it was which question?
7.
Okay, that's what I thought it was. Okay, so we want to list all the possible zeros. So that's the thing where, remember, we're doing this here. Okay?
Okay.
Wait a minute, where was it at? That's why I didn't want to erase this earlier. See this? Oh, that wasn't that one either. It's where we're doing with the list all, what did it say? List all possible. So what we got to do is, and I'll just put it in a nutshell. And if you want to, I'll work it out later and send it to you. Just send me an email, okay? But anyway, what we got to do is we got to do the synthetic division. So we would put 1, 9, negative 69, and 77, okay? So it was 1, 9,
negative 69, negative 7.
And then we're gonna go through and we just.
77 negative.
Negative 77, okay. But we gotta figure out what to do, and this is the hard part. So you look at the 1 and the 77. So 77 over 1 is what we're looking for possible factors. So you just got to list them all out. So there's like 1 plus or minus 1 plus or minus, I think it's 11. No,
And minus 77.
Yeah, 7. And then there's plus or minus 77. And what you're going to do is just go through and do each one of those until you get a hit. Like I say, that's what we did over here. Where was that? I forgot now. But see, we had to go through all of them. And this is the approach that I would take on that one. I think that you're probably just going to have to find one of them. And then when you get it, find out what it is. Like, for example, like on this one, we got a hit right off when we did x is equal to 1. Because whenever you get a 0 here, that means that that one is a factor. So then what happened, what I did then, and this should work on that one, because it's just a cube. So then when you find out what it is, you write it like this, factored form, and then you solve, and it's going to be a quadratic right there. Like I said, if you want me to do it, send me an email, put it in there.
Okay.
But I'll be glad to do it, because after this class, I got plenty of time.
Yeah, I'm gonna send you one with the square. I mean x. It was like x to the 4th, and then the 3rd, and then. I think I got it. I'm in down pack, but it was something like this, but it was like, just say like it was 2x to the 4th and 5x to the 3rd. And it was.
I just need to see the whole problem, you know, so I can know what it is we're doing.
Okay, I'll definitely send you an email. Is any of these going to be on the midterm?
This is the thing we went through here, and I don't want to make this too obvious because never know who's listening. We just went through this. What was it? What did you ask specifically about? Because this, you know, this practice is about as close as you can get.
Okay, thank you.
Because, you know, that's, I mean, we're using the same kind of formula for test 1 and test 2. I mean, it's copy. I think just come out and say stuff like that.